Hey, good afternoon. Okay, good morning. Good morning and good day to you all. I think in Nigeria we're in the afternoon. In Ghana, we're still in the morning. And I think also in US. All right. So my name is Oladipo Mumin Olatunji. I will be your instructor for the day. Um, Today will be the topic of discussion will be for this particular section is why Python. I am a Once again, my name is Oladipo Mumin. I'm actually a lecturer at Koladaisi University, Ibadan, Nigeria. I teach in the Department of Mathematical and Computing Science, and I am also rounding up with my PhD in physics. And let me share my screen quickly. All right, so why Python? Of course, a number of you had participated in the pre-workshop session. And if you are here today, it means you are interested in learning Python for data sciences, especially in the scientific community. So the question you might want to ask because of the rigor that you may face in the initial stage of learning Python is why Python and why is it necessary to go through the rigor? Is it worth it? And how is it different from some of the existing languages you might have learned and some of the tools you may be using for your computing currently? There are a number of reasons why Python is a very good tool in the scientific community and why it is advancing over the last few years. The number one reason is Python has a very wide scientific community. You have a lot of support and it is robust. So we go through some of these reasons one by one. But before I go into this, some of the reasons why Python is important and why you should choose Python for your computing and data visualization. I will first want to start with the course with an introspection for myself. I started learning Python for the first time. I programmed in Python in 2018 at the COESSING event in Ghana. And prior to that time, that was just when I got admission as a PhD student at the University of Illinois. And prior to that time, I had no knowledge at all about Python. Though I had background in programming before then, I could program in a number of languages, but mainly for electronics. So the essence of actually wanting to learn Python then was I was in search of computing tools and also ideas for my PhD that could foster and help my research progress. So upon getting introduced to Python, one of the major reasons we had two options then. We had the option for learning Python and the option for learning MATLAB. But we chose, myself and my group, we chose Python. Basically, one of the major reasons was because it is free and we have community support. So we had this at the back of our mind that we learn this. We go back home to Nigeria, we will be able to continue to learn and use the language without any constraint, because already a number of us had no research funding. So it means we're funding our research ourselves. So it will be a lot of stress again if we have to still source for more money for computing resources. Now, after then, between 2018 and 2019, I had no publication at all, not even one. Yeah. So However, after 2018, upon my return to Nigeria, building on some of the things I had learned, between then and 2022, 2023, I'd already published 12 journals, including that includes about that include 8 full-length papers, both published in international and local journal, and 4 abstract presentation. I can tell you that all this wouldn't have been possible at all if I had no knowledge of Python, because having learned Python, give me a better opportunity to be able to do my computing while focusing most of my attention and energy on being able to interpret my data and my results, rather than in the previous years where I had to struggle a whole lot on the computing itself and had little time on actually reporting and interpreting the data set. That, I think, is a testimony that can help you to be able to make decision as to why it is important for you to adopt Python and learn Python for your data analysis and visualization. Now, on a wider scale, here are some of the reasons why Python is important and why it is being accepted widely among the scientific community today. Python is a high-level language, just like other high-level language like MATLAB, like the IDL and NCL. IDL is the interactive data language. So basically, the advantage that high-level language have is they offer flexibility and a high level of abstraction. Now, if you have never programmed in assembly language, you will, and if your entire journey of programming had been with the use of high-level language, you will never understand the beauty of the abstraction that a high-level language provides. Now, let me put it into perspective. I will share a part of a code for assembly language, written in assembly language, just for you to be able to write to a specific port of a microcontroller. And I will tell you how you can, I will tell you how you can do this with just few lines using a high-level language like C. Then that can give you a perception of how beautiful it is and how relaxing language as compared to assembly language or a low-level language. Because when you are writing in a low-level language, you have to specify yourself the memory you want to write into. You have to specify yourself. Apart from the memory you have to write into, if you are performing computation, you have to do the computation bit by bit yourself. If, for example, you want to display something, you have to be the one to do the entire process bit by bit. The delay process, you have to be the one to compute to design the entire loop just for you to be able to write a delay. It's a whole lot of headache. And if you have ever written assembly language before, you will be able to understand and put into perspective why it's so important and why it's a relief for you if you're writing in a high-level language and the kind of abstraction that a high-level language like Python provides. Of course, this does not come without a disadvantage. One of the disadvantages of writing of this abstraction is that it's not memory efficient, because by trying to provide a layer of abstraction, there is a trade-off, of course, which is normal in most scientific inventions. Now, Again, now to put that into perspective, as I've said, let me share a screen, just part of a code written in Python, written in assembly language. Okay, can everybody see this page I've opened, the PDF I opened?
Yes, yes.
Okay. Now, here is a code written in assembly language. The purpose of this code mainly is to be able to write to a port, just like you want to blink. For example, you want to blink an LED on a port of perhaps your microcontroller. That's the only thing that this code is meant to do. And the first thing you have to do is to specify the bank of the memory, the bank of the memory. You write specifically. You specify the memory, the part of the memory that you intend to use. Now, having done all these parts simply in a high-level language will be done in the background. You don't have to know. Again, you have to specify each of the part of the memory you are writing into. All this part of it are not even done, you don't even have business with it. Now, here you then start to write to the port. Normally, if this is a high-level language, all this part with a single instruction line, or at most two. If you always have to import a library, or you just have to specify that port alone, to declare that port alone. So with one or two line of instruction, 1, 2, 3, all these 7 instruction line can be replaced with just 1 or 2 instruction line in a high-level language like C. Now, this part simply you could just write it with, depending on your level of proficiency with the language you are using. 2 to 3 instruction lines can replace all of this. Now, with this kind of abstraction that a high-level language provide, it makes it easier for you to be able to, if you are doing data analysis, for you to be able to do your data analysis faster and more efficient. If, for example, you are using it for applications in instrumentation, it helps your prototyping to be very, very fast, because you don't have to deal with the nitty-gritty of knowing where your program is being stored, knowing the step-by-step process of how the instructions are going, because libraries are just there, which are provided by the community. Individuals add input to this, add input to the language, and you can simply just go, for example, to a library, import the library, and you have a whole lot of functions that can do wonderful things for you. So this is one of the advantages that you could have learning Python. Then number 2, interpreted languages. Most of your work is probably already in interpreted languages. Of course, a large number of us will be currently using IDL, NCL, or MATLAB, and other high-level languages. So you're already familiar with the advantages of this. You don't have to worry about compiling or machine compatibility. It is portable. Now, one of the things you could that is also very important is machine compatibility. When you are trying to when you are writing in Python, for example, it is universal. You could write the same code that will run across various platforms without necessarily have to worry about recompiling your code on each of these platforms. Unlike low-level languages where this is a whole different ballgame when you are doing that in low-level languages. And again, of course, the downside is it's slower. This is one of the things you will learn. But however, in most of our applications, in most of our applications, the little difference in, the difference that we have in the speed of low-level language to high-level language is still not sufficient enough. It's still a good trade-off for most of the applications we'll be needing for our computing and our analysis. Yeah, so it's mainly in the area of instrumentation that, in some application in instrumentation, that some of these may matter a lot in terms of the speed and trying to choose between the assembly language and this kind of high-level language. Now, Python is an object-oriented language. What do we mean by being object-oriented? It means that you could have some custom data types. Well, for every of these custom data type, you usually have a set of operations that this might conduct. So, for example, you want to perform a correlation. You already have, and this correlation, you want to perform it, for example, on an array of data set. That means maybe, for example, you have a data set for maybe 3-4 locations for maybe like a whole year, and you want to perform, then for that particular 3-4 locations, you have various data that you have collected at those locations, and you want to just have a correlation across board. Now, by this, you don't have, normally if you want to do this manually, you have to do each location on another location, You can imagine the whole time and stress that takes you. However, you could just perform this operation across board using certain instructions, certain function, just like CORR, correlation, and we have a lot of functions that you can use across to do all of this, to do numerous statistical analysis for your Python. So, and in fact, there are almost no or limited number of analysis you want to do today that you already don't have a community that has already worked on it and a community trying to build or to improve it. So again, Python is open source, and this is one of the greatest advantage that you could have for wanting to choose. One of the greatest motivation you could have for wanting to choose Python for data analysis and for your other scientific application. Here, of course, a number of us here in COESSING, we are researchers and we are early careers in West Africa, and we know, of course, that one of the major challenge of research and science in West Africa is access to funding. Science is not cheap, and of course, we could get insightful data from even low-cost instrumentation and some data. However, if after sourcing for instrumentation, getting data, you still have to labor over getting access to computational resources that you need, then you can imagine how that can affect your output, your research output as an early career. So we're still struggling to be able to get a foot on ground in the science world. So Python is open source, and it has a community of developers behind the code base. And at any point in time, whatever project you are working on, you could always have support whenever you are stuck. So it means if you start a project, for example, or you start an analysis and you need a particular tool and you get stuck trying to learn or to implement a particular code, you definitely will be able to get help, not just from people within your local environment, but from people all around the world. And because it's open source, individuals also have the ability to be able to add to the community code base. For example, you are working on a particular tool, and you discover, well, what you intend to, perhaps what you intend to use it for, the code had not yet been written to be able to do the specifics. You could use the community to be able to write and develop that solution. Then you turn it in to the community so that others, when they are coming, they are able to use it. You get credited for it, and you are also participating in advancing knowledge and making life easy for others. So these are part of the reason why writing and learning Python is very important. And again, application. Python has a wide application, ranging from web designing to artificial intelligence to data science, machine learning, instrumentation. Just name it. Python will be able to do it for you. So it means by just learning Python, it is sufficient for you to be able to move and apply it in various applications without necessarily worrying about without necessarily worrying about what, there are certain programming languages that you learn and they are just specific for a particular application. Python is universal. And again, the platform is robust. So it means even if you had a knowledge of a particular programming language previously, for example, C or C++, on the Python platform, there is a way you could be able to integrate the previous code you've written is in those languages with Python, and it will still be able, you will still be able to run it. So it means this will provide you with a way of being able to update your code base and update previously written softwares without much hassle. So these are some of the wonderful reasons why it's very important for you to learn Python. I have learned Python, and I can say from introspection that it is one of the greatest and the most defining contributions. The best decision that I've made in terms of my career path. Learning Python had been one of the greatest decisions that I've made, because it had greatly impacted me and my career. So on this note, I will entertain comments and discussions within the next 20 minutes. Thank you very much for having me. So if you have any questions, contributions you want to make, please do. So while we are waiting for contributions, now if you intend to if you intend to ask a question or make a contribution, the format will be that you introduce yourself, then tell us your affiliation and a brief description of your research focus. Then you ask a question. Okay, good. In the absence of any question, while we are waiting for people to ask question, may I, may we use this time, maybe we could use this time to be able to set up our, um, to be able to set up our Jupyter Hub net platform. It takes a little while to load, so we could use this time to load it, so that when we are coming for the section, for the next section, we already would have gotten it, especially for those who must have missed the pre-workshop. Daniel, is that okay? While we are waiting for people to ask questions.
Yeah, definitely. I'll try to also send the links in the chat. So yeah, you can go ahead.
All right. So while we are waiting for people to join, now a link had been shared earlier to for the Jupyter Hub. Let me share the. Do you have the link for the Jupyter Hub?
Yeah, I'm trying to send it in the chat.
Okay, please send it in the chat. Now, for those who are unable to join the Jupyter Hub, you may need to share your email with us. Okay, thank you very much, Daniel. So Daniel already has shared that. Please click on that link. If you are unable to log into the Jupyter Hub, then it might mean that you are yet to be added to the hub. So please share your email, let us know, and share your email address with us so that we could add you to the Jupyter Hub. That is the platform we'll be using for the rest of the Python training. Someone is making a contribution. Is someone making a contribution, please? All right, so that will be the platform. Yeah, so Daniel already has shared, he had already shared a form you can fill if you had not been added to the Jupyter Hub. Please, I want us all to do that. All right, so we have an email. Please, Glory, please fill the form. A link to a Google form had been shared. Fill that link so you could be able to access it. So we'll be currently we have to add you individually, manually, I mean. So it means it is important for you to fill that form immediately so that we'll be able to add you to the platform.
I fit take. Hmm?
Now, for those who already have it opened, you'll see coincing Python 2023, then Patia Foundation. Under that, we have the foundations, and a number of what we'll be using today are in here. So the link to Jupyter has been sent. Okay, someone is requesting for it to be sent again. I'm copying as we send it now. Marilyn, I've sent it. If you're unable to log in, it means that you may not have been added. So fortunately, we have to add you manually. So please fill the form, the Google form that had been sent. I will send it again. Daniel already shared it, so I will resend it now. I will just copy and resend it. So if you are unable to log in, fill the Google form so that you can be added manually before the next section. Then if there's any question or contribution to the what we have discussed, we still have about 8 minutes before the break to be able to ask our questions and make our contributions. Thank you. Someone is asking if I can explain how to use Jupyter Hub after accessing it. All right, so I'll do that quickly within the next 1 minute that we have left. All right, I'm sharing my screen now. So I think our time is up. If our time is up, I can do that within the first 15 minutes when we come back from our break. Is that okay? I will do that in the first 15 minutes when we come back for our break. So thank you, Daniel. Daniel had added everybody who just filled the form. So someone is asking, I've asked to be able to, for me to explain a bit how to use it. So when we come back from the break, I will use the first 15 minutes to explain how to use the Jupyter Hub. So we go through that to be able to access our the material we need for the current tutorial. Then after we then start the tutorial for the day. So, all right, so we will meet in an hour to begin the tutorial for the day. Thank you all. See you soon.
Actually, I think 2 hours because we have the opening ceremony.
Okay, 2 hours.
We have the opening ceremony in an hour. And the recording. Oladipo, the recording. You need to stop it. Yes. Oladipo.